Hello, everyone, and welcome. You've probably heard the term artificial intelligence or AI everywhere. But what's the engine that powers so much of it? Often, the answer is an artificial neural network. So, what is an artificial neural network or ANN? Simply put, you can think of it as a digital brain. It's a powerful computing system inspired by the structure of our own human brain, designed to learn patterns from data. This is the core technology behind so much of the AI we use every day, from AI chatbots to your phone's facial recognition to recommendation systems on your favorite streaming service. But here's the key: a neural network learns by example, just like we do. You don't program it with millions of IFN rules. Instead, you train it on a large amount of data, and it figures out the rules all by itself. To understand this, let's look at the brain analogy. In your brain, you have billions of cells called neurons. These neurons are connected to each other by synapses. When you learn a new skill, like riding a bike, the strength of the connections, the synapses between specific neurons changes. That's learning. An artificial neural network mimics this. It has neurons or nodes. These are small computational units that receive input and produce an output. Connections or weights. These are the links between the neurons. Each connection has a weight, which is just a number that represents the strength or importance of that connection. And the entire process of learning is simply the network's process of finding the perfect set of weights for all these connections. So, where do all these neurons live? They are organized into three types of layers. First, the input layer. This is the front door of the network. It takes in the raw data. For example, if you're analyzing an image, each neuron in the input layer might hold the value of one single pixel. Second, the hidden layer or layers. This is the thinking part of the brain. The data from the input layer is passed here. A network can have one or many hidden layers. That's where the term deep learning comes from, a deep stack of layers. In these layers, the network identifies complex patterns and features. Finally, the output layer. This is the mouth of the network. It gives the final answer. If you're classifying images, the output layer might have two neurons, one for cat and one for dog. The neuron with a higher value is the network's prediction. Okay, that's a lot of theory. Let's walk through a real example. How does a network learn to tell the difference between a handwritten 7 and a 9? Step 1, the input. You feed the network a small image of that handwritten 7. The input layer takes this image in as a grid of pixels. Step 2, the first guess. This is called a forward pass. The pixel data travels from the input layer to the first hidden layer. Now, imagine different neurons in this hidden layer are tuned to look for specific shapes. One neuron might activate if it sees a horizontal line at the top. Another neuron might activate if it sees a long, straight diagonal line. And a third neuron might be tuned to see a curved loop at the bottom. For our 7, the horizontal top line neuron and the diagonal line neuron activate strongly. This result moves to the output layer. The network then makes its first guess. Okay, based on that, I'm 80% sure this is a 7 and 20% sure this is a 9. Step 3, the aha moment. This is called backpropagation. The network compares its guess to the correct answer, which we, the trainers, provided. That was a 7. The network now calculates its error. Then, it goes backward through the entire network and adjusts all the connection weights just a tiny bit. It strengthens the connections that led to the correct 7 guess. And it weakens the connections that led to the wrong 9 guess. Step 4, repeat. This is training. You don't just do this once. You do it thousands or even millions of times with many different examples of 7s and 9s. Each time it guesses correctly, it reinforces those connections. Each time it guesses wrong, it corrects itself. So, what's the result? After all this training, the network's weights are perfectly tuned. It has learned the core patterns, the essence of what makes a 7 and what makes a 9 a 9. Now, when you show it a new handwritten number it has never seen before, it can make an incredibly accurate prediction. And that, in a nutshell, is how an artificial neural network learns. It's a digital brain that learns from examples by finding patterns and adjusting its connections. I hope this explanation was helpful. If you learned something today, please give this video a like and be sure to subscribe for more explanations of complex tech topics. If you have any questions, drop them in the comments below. Thanks for watching.